people struggle with probability as a topic in high school. You'll do it next year as in ninth grade. It's also, so it's good to get exposure to this earlier, and it's on the SAT too. So I don't know, you guys didn't cover it this year, but it's good to actually learn a little bit. Okay, so anything on page 1, I noticed some things, some of you guys got confused between permutation and combination. Like this one, some people were writing 0 because they're thinking it's combination 6 out of 6. If it's combinations like this one, combinations 5 out of 5, usually it's written this way, C 5 out of 5. How many ways are there to pick 5 items out of 5 if you're supposed to pick 5 unique items? If you say I have 5 keys on the table, I need to take all 5 keys. There's only one way to do it, take all 5. Doesn't matter the order in which you pick it, there's only one, right? So combination 5 out of 5, combination 0 out of 5, picking nothing from 5 is also only one way. But if you think about permutations, it's not 1 or 0. Permutations like this. So how many ways are there to arrange? Remember, permutations is with order. How many ways are there to arrange 5 items, right, in a row? So there's 5 factorial ways. There's 5 possibilities for the first item. Then the next item, you have 4 possibilities, 3, 2, 1. So there's going to be a lot of them, right? So 10 times 12, 120. Permutation 6 out of 6 is 6 times 5 times 4 times 3. So 6 times this, 720. Right? Combinations, though, is different. Combination 10 out of 10 means from 10 pick 10, or you can think of it as from 10 pick none. Picking 10 items out of 10 is the same as picking no items, right? You could pick them all or pick them none. Pick none, this is one way. Permutation 1 out of 11 is 11. If you had 0 out of 11, how many ways is there to pick 0 items? There's only one way to do it, right? Combination 2 out of 11, that'd be what? 11 times 10 divided by the repeats, 2 times 1. If it's permutation, you just do 11 times 10. If it's combination, you cannot do repeats. Like if you pick item A first, then B, or B first, then A, that's the same combination. That's why we divided by 2 times 1, right? That's where that comes from. This is 55. Okay, any other issues on this? Second page. Yes. Anything else? Page 2. I assume nothing, right? Page 2, no issues. Difference between permutation and combination. Permutation order matters. Combinations, this one order matters, right? Order affects your permutation, but this one order doesn't matter. Okay, anything else in here? Any problems? Nope. Page 3. On page 3, you said there was a mistake at the very top. Maybe we did it wrong. I don't know. 1, 2, 3, 4, 5, 6. There's 6. It says, what's the probability of picking 2 even numbers? I think I must have done this wrong. If 2 different numbers are picked from the set. So you pick 2 out of, maybe I said there's 7 numbers. There's actually 1, 2, 3, 4, 5, 6 numbers. So pick 2 numbers out of 6, 2 unique numbers. I don't care the order in which you pick it. Picking 1 then 2 or 2 then 1 is the same. So we do combination. How do I pick 2 evens? So pick 2 numbers that are even. How many even numbers are there? 3 of them. So of those 3 even numbers, take 2 of them. So when you do this question, you can think of this as 3 times 2 over 2 times 1, or you can think of this as C1 out of 3, either way, right? So you could say, I pick of 3 things, I have 3 items. I could pick 2 of them, or I could get rid of the one I don't want. That's the same thing. If you want to select 2 items from 3, you can also eliminate the one you don't want. 1 out of 3 is the same as 2 out of 3. So this answer will be 3 over, this one we know, 6 times 5 over 2, right? Times 1. So you know this is going to end up being 3 over 15, which is 1/5.
Oh, it's because,
yes, what did I write?
I think instead of 6, you wrote 7.
Oh, I wrote 7 as total number. I must have thought in here there was 2, 3. There's 3 missing. The 3 is missing. I thought there was 7 numbers. They're not 7 numbers. Okay, anything else? Anything else you guys got wrong? Nope. Okay, next page. Page 4. Any problems on 4? You can just ask. If you got it wrong, probably someone else also got it wrong. Page 4? Nope. Page 5? Nope. Okay, next one. Page 6? Okay, anything else? Just on the probability one, permutation? I think we did most of these. No issues. Okay, good. Okay, starting from page 7, reviewing, right? Reviewing for
I got one wrong.
page 7.
I got 2 wrong.
Okay,
Wait,
so these are clear.
I got marked wrong.
I don't know. I'll take a look.
Too messy, Kate.
Okay, page 7. Factoring. These are obviously what? Difference of squares. Do not square it out. I saw some people squaring it out. Do not square it out and simplify. This is asking like a squared minus b squared. Factor it as a plus b times a minus b. So the first thing, or you can think of square minus triangle. This is square plus triangle and square minus triangle. So do not actually square it, okay? So you're going to do what? This is 2 squared, watch out, not a 4, right? 2x minus 3 whole thing squared. So you're looking at this thing and this thing. So add them together, so you're going to say 2 plus 2x minus 3. The other one could be, watch your negative. It's 2 minus, technically the whole thing. If you're going to forget it, put a parentheses there. It's 2 minus the quantity of 2x minus 3. So it's going to be 2x minus 1. Here, change the sign, right? It's going to be a negative 2x plus 3. So 2 plus 3 is 5. That's minus 2x. And then you always check to see if the binomial has any more. If this were like a 2x minus 4, you have to factor further. If there's nothing else, you can leave it, right? You don't necessarily have to factor out the negative. Does your teacher want negatives factored out if there's a negative here? Leading? No leading negatives, you can leave it. Okay. Okay, any other issues when you're looking at this? What's the difference between that and equations? So when you're solving an equation, you have to get an answer, not factor, right? So we could still do difference of squares here. 1 plus 3 minus 4x. And 1 minus that quantity. 1 minus 3, change the sign, plus 4x. Equals 0. Don't forget to write equals 0. Simplify, we get 4 minus 4x and negative 2 plus 4x. Solve it, so x equals to 1. That's one of them. The other one, x equals to what? Half, right? 2 over 4. So half or 1, both of them. Okay, any other problems on here? Number 8. Let's look at number 8. Number 8 here, this is what? You have to square root these. Remember, it's 9 of square like this minus 4 of triangle like that. That's a 3 squares plus 2 triangles, right? And then 3 squares minus 2 triangles. Whoops. So don't forget to square root. So sometimes people then put the 9 in there. It's going to be what? 3 times of 2x minus 1 plus 2 times of 2 minus 3x. The other one, multiplied by 3 times of 2x minus 1 minus 2 times of 2 minus 3x. Okay, you can't leave anything with parentheses within parentheses. That means you need to simplify. You need to multiply these all out and then do the like terms. So I have 6x minus 6x, no more x. Negative 3 plus 4, so that's 1, right? So that's actually gone. That whole thing's 1. The next binomial here, 6x plus 6x, that's 12x. Negative 3 minus 4 minus 7. So it's just 12x minus 7. You don't even need the parentheses technically, right? This is already factored. Done. Okay, how about the next one? The next one asks you to solve. So in the solving question, you're just saying basically factor, and you have to set equal to 0. So it's going to be x equals to 7/12 is what you'll get there. Okay, next one, simplification, number 10 and number 11. Here, what do? When you do division, what do you do the exponents? Exponents are what? Subtract. So you subtract the exponents, you could see it'll be what? This 6 to the negative 1 means 1 over 6. So what's 5 over 1 over 6? So clearly that's 5 times 6. So 30 on the numerator. And then after that, look at your x. Subtract the exponents. Negative 2 minus 5. Minus 3 is negative 5. The other one, y, if 3 minus negative 1 is 4. So you don't usually want negative exponents. You'll write this as 30 y to the 4th. You'll leave the 5 on the bottom, right? X on the bottom, sorry. X to the 5th on the bottom. Okay, next one, number 11. How do you handle this one? When there's a square root down here, but there's a plus there, that means you need to do conjugate, right? So you have to do 3 minus root 2, 3 minus root 2. Difference of squares on the top, 3 times 3 is 9. Minus root 2 times root 2 is 2. Numerator, first to first, 6. Outside, which is what? Negative 2 to root 2, and then negative 3, so negative 5 root 2. Last to last, root 2 times root 2. Okay, simplify that. So 8 minus 5 root 2 over 7. All right, that's it. Next one, turn the page. Page 8, problems here.
Why did you do number 3?
Okay, let's look at that. Page 8, number 3. Okay, on number 12 also, let's do that. So we'll do that until 12. This is an easy
How do
one.
you
Okay.
2, 4, 5, 6,
I
10,
got no
13, 14?
solution.
Oh, you just don't know how to do exponents. Let's do
No, I
exponents.
didn't.
Okay, on exponent questions, what is the best way? If you see something like x to the 2 over 3, what is the meaning as a radical? It's x to the second and then cube rooted, right? The one underneath is the index of the root. The 2 is the power. Okay, so when you do this one, the easiest way is simplify it down to the most basic. 8 and 27 are the cubes of 2 and 3, right? 2 to the third and 3 to the third is there. Then take the whole thing to the power of 1/3. Now when you do power to power rule, remember this, a to the n whole thing to the m, what is that? Is it n plus m or n times m? You multiply these together. Now why does it work like that? If you think 2 to the second or third power, whole thing to the second, this is not 2 to the fifth, it's 2 to the third times another 2 to the third. I have how many 2's? How many total 2's? 6, right? Because it'll be 1, 2, 3. And then another 1, 2, 3. Obviously I have 6 2's. That's why we add when it's the same base. When it's power to power,
Wait,
you
wouldn't it be
always
2 squared to the
multiply.
cube root? Wait.
What are we talking about here? No, I'm just giving you the power rules again.
Okay.
So first, power to power, if it's like this, you multiply these together, right? Multiply. If it's like this, it's 3 times 2. If it's 2 to the third times 2 to the third, you add the 3's together. We know that. Now, if you look at this one, once you have this, do power to power rule. What's 3 times 1/3? It's 1. So what's my answer? 2 to the third whole thing to the first power. So you just, that's it. Over here, you write this as negative 2/3 whole thing to the third, right, give you that one, right? All of this is to the 2/3 power. What do you do for exponent to exponent, power to power? You multiply. You'll get negative 1/2 to the power of 2. When it's to the power of 2, what happens to the negative? Gone, so it'll be positive 1/4. Except, one second here, 2/3. This is maybe an error in the answer. Hold on. 2/3 to the third is 8/27.
You change it to 1/2.
Oh, I changed it to half there. Sorry, I don't know what I was thinking. I was thinking of something else over here. This is not half. This is negative 2/3. Square it, so it's 4/9. Yep, so 4/9 is it. Okay, look at the next one, number 3. Number 3, same thing, use cubes. So this is negative 2 over 3, whole thing cubed, right? All of it to the 1/3 power. 1/3 and 3 cancel, so the answer is negative 2/3. Next one, number 4. 81 and 16, was that to the 4th power? Yes, 2, right? So you could do, that's a 2 to the 4th. The top is a 3 to the 4th. Is that right?
Yes.
Yeah, and then all of it to the 4th root, negative 1/4. So multiply power to power, 4 and 1/4 cancel, it's negative 1. So it becomes 3/2 to the negative 1. What does negative 1 mean? Reciprocal. Don't put a negative, yeah. Next one, half just means square root. So there's nothing to do here. You have to square root and you have to rationalize. So when you have the square root of 3/2, you know you have to times root 2 top and bottom. So then the denominator will have a 2, the numerator will be a 6. Yeah. Next one, number 6. I think a lot of you guys had trouble with this. Okay, so 6 is tricky too. This one, you see how there's nothing I can simplify power to power? You have to just write it out. It's going to be 2 over 3, 2 over 3 whole thing squared to the 3rd root. So now you got to think, what should the denominator be to get out of the cube root? I have 2 3's on the bottom. So you think, how many more 3's do I need? One more. So I take times the cube root of 3 on the numerator and the cube root of 3 on the denominator. Simplify, you have what? 1, 2, 3 3's, so one of them pops out. On the numerator, are there 3 of anything? There's 2 2's and a single 3. Can that get out? Can't, so you have to leave it under the cube root, times it together. 4 times 3, which is 12. So it's a cube root of 12 over 3. Next one, number 7. That's square root, right? 1 over 2. So the square root of 1 over 16 will be 1/4. Next one, this one, write it as a power. What's 4 over 9? It's what squared? 2/3 whole thing squared, everything to the power of 3/2. Cancel, 2 times 3/2. The 2 cancels. So it's 2 to 2/3 to the 3rd. So you could do that. It's 8 over 27. Yeah? Got it? Okay, any other issues? You said someone else asked on this one. This one, don't square. Use square root concept to do it, number 12. So here, what's the best way? Actually, look at the prior one. On these, you could divide this first. Right, get rid of that first. Then when you root it, what happens when you square root a square? Do you not say x? It's what? Absolute value x. So that's where the plus minus comes in, okay? So when you do the absolute value, you'll end up with, like, if I have x squared equals to 4, you'll technically get when you root it, absolute value x equals to 2. That's why you get plus minus 2. Okay, so here you have a plus minus as soon as you root it. So it's x plus 2 is plus minus the root of this thing. And then you have to rationalize. Then another mistake people are making, they're not writing it as one fraction. So this will be negative 2 plus minus, look at the numerator, it's a 6 on the bottom of 2. Can you leave it like this? You cannot leave the answer like this. If there's a fraction on 1, you need to make both of them have the same denominator of 2. Okay, you have to fully simplify. You will not see an answer like this on the SAT or a standardized test. You write this as put 2 on the bottom. If there's a 2 on the bottom, that needs a times 2. So it'd be negative 4. Negative 4 over 2 is negative 2. Plus minus root 6. You need to make the same denominator to make it happen. Yes, you cannot leave your answer like that. Okay, next one. When you square root on this one, 5 minus 2x, we prefer not to have a negative. So could I have just changed this to this? Why is this allowed? It's a square, 2 of them. So basically in changing both, I changed the sign twice. Basically, I took out a negative on this one. That creates 1. And then I take out another negative on the other one. So if you take out 2 negatives, it becomes a positive. That's why you can say the square of 5 and the square of negative 5. They're the same. Okay, so I change the sign, square root it now. 2x minus 5 is positive negative root 11. Keep going. 2x equals 2. Add 5 on both sides. Last thing, divide everything by 2. So I get 5 plus minus root 11 over 2. Okay, any other problems here? Number 14. 14, it's not factorable. What do you do when it's not factorable? Complete the square or quadratic formula. Yeah, so you have to know how to do those things. Okay, so if you're doing quadratic formula or completing the square, let's practice completing the square. Since you guys are good at quadratic formula, what if they ask you to do completing the square? Leading coefficients 1. Leading coefficients 1. So I have x squared minus 2/3 x. Leave the blank. I'm going to complete the square. And then instead of dividing this guy by, let's see, I have to divide that by that. So I have to move this 4/3 over. So what is our perfect square? Shayna, what's the perfect square in this case?
It's 4,
No? You already forgot how to complete the square?
wait, no, because it goes 2 over 6, and then it does.
But you reduce, right? 2/3 times a half. 2/3 times a half. It's 1/3. 1/3, and then
I
what?
thought I was doing that.
1/9.
1/9 squared. So it's x minus 1/3 whole thing squared. You half this one, you put it here. But you have to reduce. Don't leave it as 2/6. So the 2 reduces. It's a 1/3. 1/3 squared is a 1/9. If you add 1/9 to the left, you have to add 1/9 to the right. Simplify. Write a 9 on the denominator for everybody. So this will be times 3, times 3, times 3. 12 plus 1 is 13. Now you take the square root. So from this step, what do we do? What's the next thing? Chi, what do we do next?
Do we need to solve it by completing the square?
No, but I just want you to practice. What is that? X minus 3 equals to
1/3 equals to
plus minus the square root of 13 over square root of 9, which is 3. And then you need to write everything with denominator 3. So x equals 2. It happens to have denominator 3 there, so you're in luck. Combine that. So 1 plus minus root 13. Yes, quadratic formula is fine, except if your teacher says show work with completing the square. So we should practice completing the square also. Okay, next one. Page 9. Questions here. It's more of the same, right? Powers, practicing our powers. So square root, this means square root 16. So obviously that's 4. Here, this one you write 2 to the 4th. Write it with an exponent, right? Smallest base to the 3/2. Power to power means multiply these two. So it becomes 6. So 2 to the 6 we know is 64. Right? Here, same thing. 2 to the 4th whole thing to the 1/4 power. 1/4 times 4 is 1, so it's just 2. Here, what do you do in the same power? Same bases, different powers. Jenna, what do we do? Number 4.
I think you add the powers together.
Add the powers together. Yeah, so you said add these two since they have the same base. It's 10 over 5. That's a 2, so it's 9. Same thing here. 4 to the 4 over 2, which is 2. Answer is 16. How do you do the root of a root? So the root of the root just becomes a what? What does this mean? You put those indices together. So it's actually 2 to the power of 12 over 4. Yeah. So this 2 times 2 comes together on the bottom. So it becomes 2 to the 3rd, which is 8. Okay, next one. How about the number 7? What do you do for number 7? What do you do for this one? So 2 to the 12 divided by 3 times 2, 6 on the bottom. So it gets 4, right?
How you multiply?
These are two indices, right? You cube root a square. So basically, first one's asking you this. It's saying 2 to the 12 over 2. Is that the inside part? When you're done with that, what is the blank over that? Is that 1 over 3? You see that? That's why you times the 2 and the 3 together. It's a power to power rule. You see this is 2 to the 12 over 2. That's the inside. All over, all to the power of 1/2. So when you multiply, that's why we're doing 2, 2. The indices times together when they simplify. That's the reason that works. Okay, next one. 2 to the 12 over 12, clearly, right? 6 times 2, so it's 2. 12 to the, or 2 to the 12 over 12, so it's just 1, right? So it's just going to be like that. Okay. Next one. These are really easy. Division, obviously, you subtract the exponents. I don't think anyone had trouble with this. You get 2 to the negative 1, so it's 1/2. 3 to the 1, right? 3 to the third, which is 27, etc. Next one, turn the page, page 10. Problems here? Mainly would be if you made mistakes on the plus minus, page 10. So here you're squaring, right? The square root. This is number 1 and number 2 are the same thing. You square this equals square. Do you have plus minus on squaring? Some people are throwing plus minus on everything. Why can't you do plus minus on this? If you plus the minus, what's the square root of negative 25? Can you do it? No such thing. You can't have negatives under a square root. So when you square something, don't add plus minus. Only when you root a square. Okay, so the next thing here, no solution. Obviously, no solution. Square roots can't be negative. Here, remember, it's actually absolute value x equals root 6. That's why you're going to have a plus minus. X equals to plus minus root 6. Same thing. X equals to plus minus root 2, right? Actually, not root 2. No root. Sorry. What am I thinking? No root. It has a root already. It's just plus minus 6. There's already a root here, so it's just going to be plus minus 6. Can go there, right? Same thing with this. Absolute value x is 2, so x can be plus minus 2. Next one in here, all of these are the same thing. Look at number 12. Number 12, absolute value 2y minus 1 equals to 2. So when absolute value equals 2, it means two answers. 2y minus 1 may be 2, or 2y minus 1 could be negative 2. No, this is already rooted. There's no squaring to do. This whole thing, this is rooted, but that's not rooted on the right. So when you root this one, you have to realize it's absolute value. Don't root that one or square it. You're not doing anything. You just got to square root that. So here when you simplify, you end up with 2y equals to 3. This one's 2y equals to negative 1. So y equals to 3/2. Or do I have to check my answer on this one? No, right? Because it's a number over here. We're okay. So both of them are solutions. Yes. Next one. On page 11. Page 11, there's square rooting in this process, right? So page 11, we've got, so most of them are pretty easy. Look at number 3. You have x minus 1 whole thing squared equals to 16. Then you square root it. So x minus 1 is plus minus 4. It's because you're doing this. That's the absolute value x minus 1 part, right? I root that like this. Then you get the plus minus. I'm skipping this absolute value step. Okay, so this is x equals to 1 plus minus 4. You cannot leave your answer as 1 plus minus 4. It's 1 plus 4, which is 5. 1 minus 4, which is negative 3. Okay, don't have to check your work on this one. Any other ones? Turn the page. Page 12. Page 12. Page 12 number, let's see, nothing too tricky. Most of them are really easy. So a few simplification questions, but not too hard. Like the number 5. Okay, number 5, you've got 6. Let me see. This is number 6. What number is this for you? Mine is numbered differently. What happened with this one? Page 12? This is page 11. Sorry. 11, page 12. Number 5. Okay, so like this one would be, divide this over 1/8. Take the square root. S plus 2 is positive and negative. Square root of this, which is 1 over 2 root 2, times top and bottom by root 2. Simplify it. You'll get plus minus 4 here, root on the top. Cannot leave it with a negative 2 like this. You can't leave it like this. So if you can't leave it like this, that means you need 4 on the denominator for everyone. You need to make the negative 2 into a negative 8. Times it by 4, right? Negative 8 over 4 is negative 2. Then plus minus root 2. Okay. Any other issues? Next page. 13. I saw a lot of you miss word problems. I did the last 3 word problems in class last time. Yet, page 13, you still missed all of those, right? You didn't get them right to begin with. Let's look at them again because I think they're important. You need to know how to do these types of area word problems. Okay, look at number 1. A swimming pool of 6 meters wide and 10 meters long is surrounded by a uniform walkway. The walkway equals the area of the pool. What's the width of the walkway? This is a standard question. For sure you'll have it. Okay, so you're going to have that. Yeah, question.
Miss Brown, will you want us to write down the right equation?
Oh, you don't need to like solve it?
What the actual hell?
Wait, what?
Mitchell.
I can't, I was gonna say that.
Wait, why did I write that wrong?
What?
He means like he doesn't have to work it out. You just write the expression is what he's
Yeah.
saying.
Wait,
Okay.
is that, you guys want me to solve it?
We don't?
Oh, but you should know how to in case they ask. Okay, so this is uniform width.
Just remember, it's 2x plus something and 2x plus something, and just multiply that.
Yeah, it's pretty easy. Okay, so you have a pool like this, and they told you that this area here is same as the area of the inside. Okay, so we know it's 60. That's kind of given already. So we know the length. That's 2x plus 10. The other one has another 2x here, 2x plus 6. So we would do the outside, 2x plus 6 times 2x plus 10. Okay, now subtract off the inside of the pool, so the inside's 60. What should that be? Because they already told you that the area of the walk equals the area of the pool. You know the area of the walk then, 60. So you're saying the outside rectangle minus inside rectangle has to be 60. Do you guys catch that? The walkway is the same as the area of the pool. So then outside rectangle minus inside has to be 60. Simplify it. So we have times it, you get what? Times this out, 4x squared. Outside, inside, 20 plus 12. So 32 plus 60 minus 60 equals 60. So that's gone. So I could divide everyone by 4. X squared plus 8x minus divide by 4. So 60 divided by 4, you'll get, what do you get? 15, right? And equals to 0. So we need two factors of 15 that subtract to be 8. Are there any? This is where some of you got stuck. You thought it was addition. You did 5 and 3. It's not factorable, right? So we can't factor this one. So in that case, you have to do quadratic formula. Yeah. The x equals to quadratic formula. Yeah. Okay, so it's negative 8 plus minus root b squared, so 8 times 8, 64, minus 4ac, so plus 4 times of this, 60 over 2a. Simplify, root 124 has a 4 in it, so that's our perfect square. Take out the 2. So I have negative 8 plus minus 2 root 31 over 2. Everybody divide by 2, you'll get negative 4 plus minus root 31. Now you have to think to yourself, are both of them actually answers? Why is one not an answer? Negative 4 minus root 31 is a negative number. You can't have a negative with walkway, so the negative one can't count. It's just going to be negative 4 plus root 31. Root 31 is bigger than 4, because root 16 is 4, right? So root 31 is definitely bigger than 4. So your answer is that. It's just negative 4 plus whatever it says. Write your answer to the nearest hundredth. So if you use your calculator, you'll get 1.57. That's your width. It's negative 4 plus root 31. Okay, next one, number 2. Each side of a square is 4 meters long. When each side is increased by x meters, the area is doubled. Okay, let's think about what's going on with this question. They're saying each side of a square is 4 meters, 4 meters. If you increase it by x and x, get x and x longer on each side, the area is doubled. Find the value of x to the nearest hundredth. So let's get an equation for this. It's not too difficult. Your new area is double of the original, right? Katie, how do we write the equation?
4x plus 4 and x plus 6.
Yeah, squared, right? Equals the new area is
60
double of the original, so it would be
times 2.
yeah, which is 32. So you already know that. So you're saying my new square is 32 square inches, right? Don't square it, do square root. So x plus 4 is positive negative root 32. Root 32 is 4 root 2. There's a 16 in there. So one of them is probably not right because one of them is negative. Right, this one's not right since it's going to be a negative number.
Like minus 4?
Negative, yes. So negative 4 plus 4 root 2, yes. So then simplify that. Negative 4 plus 4 square root 2. If you round that to the nearest hundredths, you will get 1.66 meters. So I don't know why so many people miss these. They're not that difficult. Next one, number 3. Number 3, it says a rectangle of 6 meters and 6 by 5. When each dimension is increased by x, the area is tripled.
Oh, jeez.
Sorry.
So 6 meters,
Oh my.
5 meters, increase by x here, by x here. And then your new area is 3 times, right? 3 times of the original one. So how would I do that one? The x plus 6, right, times x plus 5 equals, I already told you, the area is tripled. So the original area is 30. So the new one's 3 times of that. Isn't that 90? That's it. Simplify. So you end up with x squared plus 11x plus 30 equals 90. And then move that over, see if it's factorable. It may not be. Factors of 60, the subtractor be 11. Are there any? So 60 divided by 2 is 30. Nope. 15 and 4? Yes, 15 and 4 is 11, isn't it? Right there, 15 and 4. So that means I need 15 to be positive. I need the 4 to be negative. I have x equals 2, can't be negative, that's out, or positive 4. So 4. Now find the value of x. X happens to be 4, there's nothing else to do. So it's 4 meters. Okay, next one. Actually, we did the next 3. Any questions on homework you're turning in today? Let's look at that.
What about the playlist?
Yeah, any of the issues on homework you're turning in today?
I don't know what the playlist was.
I think, any issues? The playlist one, you said? Which one?
Page 7, number 2.
Okay, page 7, number 2. Okay, let's look at that.
Playlists have to be at least like 2 songs.
How many, let's see what this is asking here. How many possible ways to select a playlist of songs from 7? Well, technically, okay, so if they didn't say the playlist has to be at least 2, then you're assuming one song could also be a playlist. Okay, they didn't say. Yeah, that could be. Yes, Chi.
I forgot to bring my homework.
Oh, you don't have your homework. Okay.
I finished it.
Okay. You can bring it next time.
Okay.
Go bring it next time. Okay. Select a playlist of songs from 7. So what do we think about that? Let me think about this. What you could do, you could pick 1 song, pick 2 songs, pick 3 songs. Let me think. This is actually,
Or you could just pick 7.
or pick all 7 songs. Oh, you know what? The playlist of songs, though, I think we're assuming that the order doesn't matter. Like I don't know. I have to check my answer key, but I assume for this case, playlist, we're assuming like if we have the same songs on the playlist, it's considered the same playlist versus just ordering them differently, I assume. Okay, so in this case, you could pick 1, but I can't think of an easier way to do it. You could be picking 1 song from 7. You could pick 2 songs from 7, 3 songs from 7, 4 from 7. Let me look at this. I don't know what I did on my key for that one, but it should be something like that. But that seems really 1 from 7, or it could be 2 songs from 7, or 3 songs from 7, 4 songs from 7. Yeah, it seems like a lot of ways. Yeah, 5 songs from 7. This seems too complicated though. Or you could pick 6, or you could pick 7. Right? You could pick a single song, 2 songs for it, 3 songs. But when you pick 2, you can pick like song A and B, song A and C, song D and E, right? All different things could be chosen in this case. Okay, so something like this. If you're saying I could pick 1 song, 2 songs, 3 songs, 4 songs, 5, 6, or 7, and there's many different combinations for each of those sets. What is the answer for this? This is 7. This one is not plus. This is plus. Yeah, 1. This is 1. And this guy picking 2 is 7 times 6 over 2. This is 7 times 6 times 5 over 3. This seems too complicated though. Okay, 3, 2, 1. Then this one will be the same. These 2 are the same. And then these 2 are the same. And these 2 are the same. Because picking 7 from 6 is the same as picking the 1 you don't want. So this will be identical. So when you do that, you end up with cancel, cancel, 3, cancel, cancel. Okay, so then this one ends up being 7 plus 2, 7. 2 times of 7, that's these 2, plus 2 times of these 2, 21, plus 2 times of these 2, 35, and you have one more over here. So I think you should get this many ways. So it'll be 14, 42, 70, and 1. So altogether that's 127. I have to check my answer though, see if that's the same one, but I think that's what I want. I'm assuming here that playlist doesn't matter the order. Like song 1, 2, 3 or 2, 3, 1, same. It's the same 3 songs. Okay, any others? Nothing? Okay. These are pretty easy, I think. No problems, right? Any other problems? No? Page 9? No issues, right? Okay, good. How about review on these? Any problems on these? Outlier? No problem. Outlier is when you're 1.5. I guess one thing I can mention is, what is an outlier? How do you figure out an outlier? How far an outlier should be?
1.5 of the mean.
Yes. 1.5 times the interquartile range. Yeah, 1.5 times the interquartile range, and you add it to quartile 3, or no, you start from the mean, sorry.
Oh, after quartile 3 and subtract from quartile 1.
How do you remember?
Right, from the quartile 3 out, and then from quartile 1 down. That's right. And then you can find your outliers. The first one didn't have any outliers, right? The second one does have some outliers. Any problems? Let's try one of them, okay? Okay, so on this one, yes, you have problems on the outline?
How to do the last 2 pages.
Oh, you forgot altogether vertices. That's on your final. Yeah,
It is?
vertex, parabola, yes.
Yeah.
You need
That's
to
on
know
our
that.
final?
Not parabola.
I think so. You guys did parabolas this semester.
Oh no, we had that minimum, maximum.
Mid, max, all that
range.
stuff. That's this semester.
Okay.
So on this one, did you guys get it? What did you get for your, after you get your interquartile range, you guys know this, right? After you get interquartile range, how do you find, as Mitchell just said, for your outlier, you would take the interquartile range, IQR, you multiply by 1.5, and then you take it and you add from Q3 and subtract from Q1, and you can figure out if anything is outlier, meaning it's way outside of interquartile range.
There's no way we did that.
So this would be Q3 plus IQR times 1.5. And the other possibility is what? Q1 minus whatever interquartile range times 1.5.
Yeah.
So if anything is outside of that, that is an outlier, considered an outlier, right? So if you're outside of this,
I don't even remember what we learned last time.
this
I don't remember what we went through.
range would be an outlier. So you have to check to see if any of these happen to be outliers. All right, next one. Look at number, so page 12, no problems, right? Square roots, easy. Okay, number 13, let's talk about that since you already forgot. Some of you don't remember. So here, for parabolas. Parabolas, what are you supposed to do? You look for your vertex. Remember, vertex is a shifted one, so y equals to a times of x minus h whole thing squared plus k. What is our shift? hk, right? Katie, stop copying. So yeah, vertex is going to be hk. So center, right, the vertex is going to be, h is your shift for the x, and k would be your y value, right? And then a tells you if it's a greater than 0, it is going up. A less than 0, go down. Okay, so for here, what's our vertex? Set this thing equal to 0. 1. So once that's a 1, this whole thing cancels out. You're left with negative 6. So you change the sign on this one, but don't change the sign on the negative 6. So inside the parentheses, you change the sign. It becomes 1. Outside, don't change the sign. Okay, max or min. What do you know about max or min? If it faces up and the vertex is here, it's the lowest spot. The maximum or minimum is your y value, not your x value. You're saying how high or how low. So the lowest position is negative 6. Don't write y equals. It's a value, not a line. Okay. Next, your range. Then if you're from here and up, you'd say y is greater than or equal to negative 6. Your y-intercept. How do you find something's y-intercept? You set x values equal to 0, and then you solve for y. So when you set x value equal to 0, you could see it's 2 times 0 minus 1 whole thing squared minus 6. So that's 1 times 2, so it's negative 4. Your y-intercept means you intersect the y-axis at negative 4. Next one, e, your x-intercept. X-intercept, you set y values to be 0, solve for x. So for x-intercept, if you set that to be 0, you can see it's 2 times of x minus 1 whole thing squared minus 6 equal to 0. This is where you use that square root property. So you solve it. X minus 1 squared is 6 divided by 2 is 3. Square root it. X minus 1 equals plus minus root 3. You can see the answer. It's 1 plus minus root 3. So there's 2 x-intercepts. Okay, the next one you have domain. So what's my domain then? All real, right? So for parabolas facing up or down, every x value is possible. You can go to negative infinity and go to positive infinity all the way to the right, all the way to the left. But not all y values are possible. Only y values from -6 and above, right? Next one, any other issues? Then some of the harder ones would be the not factored form. That's already factored into like HK form or what's called graphical form. That's another easy one. Let's do a more difficult one. These ones, the ones where you have to put it into graphical form to get the vertex. Well, some of you are allowed to use, does your teacher let you use negative b over 2a?
Yeah.
Do you ever have to just do graphical form?
I'm all around
They
that.
don't make you do graphical form for these. Okay, so we'll do it both ways. Let's try one where we do graphical form, because they could ask you, write this as in this format. They can say, write it in y equals a times of x minus h, like this. Write it in graphical form. It means you kind of have to complete the square. What's your first job? Leading coefficient can't be -2, but why can I not do this? Why can't I divide by -2? There's a y on the left side. You don't want y over -2. You can't do that. So that's why you can't divide in this case. You factor out. So you take out the -2. And you say this is x squared plus 4x plus blank. Complete that square. And then this 3, you write it on its own. And then you think about what's that balancing blank. So this blank will be, you need to what? -2 parentheses x plus 2. Half this number that goes there. You square it, you put the 4 here. Okay, now if I add 4, do I subtract 4 to balance it? Why can I not just subtract 4 in this other blank? Because this is -2 times 4. -2 times 4 is -8. So to balance out -8, you have to add 8, because I'm on the same side of the equal sign. So I'm supposed to do the opposite of what I just did. I add 8. So if you rewrite that, that's -2 times of x plus 2 whole thing squared plus 11. This is my graphical form, this one here. Okay, after you get that, what's my vertex? Chi, what's the vertex?
The vertex is -2.
Yeah, -2,
and
positive
11.
11, and the maximum or minimum value should be?
The maximum value should
Because it's a parabola facing down.
be.
Yeah, the y value. So maximum value is 11. That means you can answer range. Kayla, what should the range be then if the max value is at 11? Less than or equal to? Less than or equal to. Below. Y-intercept, what do we do for y-intercept? Set x values to be 0. Don't go to here, go here. X value be 0, set these first two to be 0. You can see the answer, it's 3. Then for your y-intercept, set the x-intercept, set y to be 0. Don't go back to the original one. Go to the factored form. So for the next one, you would say, I want to do -2 times of x plus 2. We're doing x-intercept now. Squared plus 11, whole thing equal to 0. Just do square root property. So this will be x plus 2 whole thing squared is 11 over 2. Square root it. X plus 2 is positive negative root 11 over root 2 times by root 2. So you get at root 22 over 2. And then get x equals 2. Write everything with a 2 on the bottom. So that's going to be a -4 plus minus root 22. So that's my x-intercept, 2 of them. -4 plus minus root 22 over 2. My domain, all real, right? Every x value is possible. Now let's do the -b over 2a way. If your teacher says you don't have to necessarily complete the square like I just did there, here's the other way. Turns out the vertex is always located at, no matter what, this axis of symmetry is -b over 2a. So if you want to find the value, you sub the x value in. That's another way to do it. So no matter what, okay, first, vertex. So what is -b over 2a? The opposite of b, which is 6, over 2 times a, which is 2 times 1. It's 3. So the vertex is located at 3. You know that. So write 3 right away. If we don't know the y value, you sub it back in. So you say it's 3 squared minus 6 times 3 plus 1. So that's going to be 9 minus 18 plus 1. So -9 plus 1, -8. So there you figure out your vertex. Once you get that, max or min. It's facing up, so it's a min at -8. Your range from -8 and up. Your y-intercept, what do you do for y-intercept? You set the other variable to be 0. That's what you always do. So set x's to be 0. So y-intercept 1. That means you cross your y-axis at 1. So if I'm trying to graph it, it's 3, -8, somewhere here, like 3, -8. You cross your y-axis at 1. like that. And then you're going to cross your x-axis at 2 spots. So if you were to try to graph this, it'd be like this. There's going to be 2 x-intercepts. So x-intercept, you set the y value to be 0, so you have to do this one. You get x squared minus 6x plus 1 equals 0. There's no easy way. You have to do what? Quadratic formula. Negative b plus minus root b squared minus 4ac over 2a. Root 32 is 4 root 2, because 16 times 2, right? Over 2. So we end up with 3 plus minus 2 root 2. So there's 2 possibilities, one here, one here. Next one, domain, all possible answers. Yeah, she.
Is domain always?
Yeah, for facing up and facing down, yes. The other kind of parabola that we haven't learned in 8th grade is this one. Next year in 10th grade you'll do it, but this kind. That kind of graph is like this. We haven't done sideways parabolas really. So this way, when it goes to the side, what's your domain in this case? 0 and up. Right? X is greater than 0. You can get those. But for us, when we face up and down, if it's y equals to x squared, this kind of graph, it's always going to be domain all real, unless it's x equals the square of y. But you guys aren't doing sideways parabolas. Okay, next, page 14. Problems here. All the same idea, right? Let's do one more type with completing the square. Let's do one more while we complete the square. I know you know how to do negative b over 2a. Let's do number 3. Number 3, use the completing the square concept to do the graphical form. So what do? If we take out what? Take out negative 3. You get, now divided by 3, x squared, so you just practice, right? Minus 4 over 3, take out negative 3, divide negative 3. Then you complete the square, you leave the 2 alone. Think of the balancing term there. Mitchell, sit up, please.
Alright.
You're tired? I know you're tired. Okay, negative 3 times, divide this guy by 2. What's negative 4/3 times a half? Is that negative 2/3? So half this number, square it. So put 4/9 there. Now you have to do the opposite of what we do here. So what is negative 3 times 4/9? So that's negative 4/3. Okay, so now if I did negative 4/3, I have to balance by adding 4/3. So plus, put the 3 on the bottom. 2 times 3 is 6. 6 plus 4 is 10. So this is the graphical form for your parabola. Okay, vertex is located at, Mitchell, what's the vertex located at? 2/3 and 10/3, yeah. Opening up or down, because it's negative. Down, yep. Our x-intercept would be, Katie, how do we find it?
Make y 0.
Then what?
And you move the 2.
No, you want to do that. No, if you make y 0, you'd have to solve this whole thing, or you could do this one. Either way, you could do quadratic formula in the first one, but since we already factored this, it's ugly though. This one's kind of ugly, sometimes it's nicer. But in this case, if you set this to be 0, you would get negative 3 times of x minus 2/3, because there's so many weird fractions, it's so ugly. But let's try. So you divide by negative 3, so you'd say put this over, it becomes 10/9. Square root it. X minus 2/3 is positive negative root 10 over 3. You can also quadratic formula the original one if you want. Okay, so x equals 2, put the 3 on the other side, put the 2/3 on the other side, 2 plus minus root 10. That's it, so that's x-intercept, 2 plus minus root 10 all over 3. Y-intercept, the easiest way, set x to be 0 on the very first one. So y-intercept's 2. Domain, everything. Range, since it's facing what? Down, it would be less than or equal to this y value. So y less than or equal to 10/3. That's it. All right. Okay, new homework. On your new homework, let's talk about that. New homework, we're not going to write on it because we're not going to do, we'll just do whatever we can. I'm not assigning it for homework. So just classwork, technically. Look at this one. I gave you a blank packet. You could write on that blank packet. I mean, don't write on the packet itself. Write on the scratch paper. The scratch paper is the one that's had scrap on the back, right? So just write on that, the blank side of the scratch paper. Okay, this part, we'll just do what we can of each one. So I'm going to pick different kinds of questions. We'll kind of get to it. Okay, so, and then we'll see if we can, how far we can get. So we have about an hour. Okay, so each type, I think the one you might struggle with the most is arithmetic and geometric progression. So I first want to talk about that. Geometric. You guys did geometric in second semester.
I don't think we're doing it.
I don't think we're doing
we
it
did do it.
Yeah, we are.
Let me check. You gave it to me right here. Let me see. I didn't copy it.
That's chapter 7?
Yes, exponential functions. Yeah, but it says
What chapter?
7. 7.
How old are you?
But it says here you're doing exponential functions. Does that count? Does that count for?
Hold on.
Maybe section 4 you're skipping or something. So 7.1 to 6.
We didn't do on the reviews.
Oh, do you know? Then probably not.
You guys-
Check 7.4. That's skipped. Is there 7.4? What is that section?
There. Yeah, some
Oh, it's scientific notation.
Oh, that's totally unrelated. But I don't know. So the rest of it. So maybe they're not doing sequences. Yes. Go ahead. Maybe. Okay. Anyway, so let's quickly talk about it. You said for sure it's not on it. Don't know.
It's not here.
No. It is, right? You guys did geometric in second semester.
Well, we have to determine if it's exponential.
Yes, that's what you need to do. Determine if it's an exponential function.
So we don't have like domain, and we don't have.
I think you have recursive. No?
No.
Is that another section? Check a different section. It's okay. I'll talk about it anyway. It doesn't matter.
Oh no, that's 7.7. We're not
is
doing
it?
7.7.
Oh, 7.7 is not included?
Yeah.
Did you do it when you took your test? Do you
Yeah, we
remember?
did.
But now you're not doing it
Yeah,
on this
we're
part.
We are doing 7.7.
No, we're not doing 7.7.
No, they have a different teacher
No, we're
than
not.
us.
Oh, different teacher. Oh, that's why. Okay, so I need to quickly discuss it. It's not that hard. We'll just discuss it. I'll give it back to you at the end of the class. Okay, we'll quickly discuss it. It's not impossible. You can get it. And then we'll do the problems, okay? So as you remember, what's the difference between arithmetic and geometric?
Arithmetic is drawing.
Arithmetic is the one where you add the
It's
same,
easier.
yes. So when you have an arithmetic progression, or you can say arithmetic sequence, either way, you would say first term, second term, third term, fourth term. You add a common difference every time. Do you remember that? This is the common difference here. So if you're interested in finding the fourth term, how could you find it if you know the first term? If I say get the fourth term, then you start from the first term. How many common differences do you add? You do what? 4 minus 1. Is that plus d plus d plus d? So if you want to get to the fourth term, you start the first term, you add 3 d's. So you would say I take the first term and I do plus 3d. What if I want the 10th term and I have the first term? I add how many common differences? 10 minus 1, 9 common differences. Do I always have to start at 1? No. It could be A5 to begin. If you start at A5, you add 5 common differences. You can start at any number here. So you don't always have to start at 1, although the general formula looks like this. A sub n is a sub 1 plus n minus 1 times d, like they do that. But you don't always have to begin at 1. That's not a hard rule. Okay, so that's arithmetic. What about geometric? So if it's geometric, instead of adding by a constant value, you do what? Multiply by. That's called a common ratio. So if you start from 1, A2, A3, A4, you times R, you times R, you times R. Right? Common ratio here. So here you're going to say, so here you say the fourth term then would be the first term times how many common ratios? 4 minus 1 is that 3? Right? Okay, then what about if I have like a to the 10 equals to a to the 2 times r to the 10 minus 2? 8. Right? That's pretty easy. But the general form is like a sub n. If you start with 1, then you say r to the n minus 1. That's it. That's all we're doing for the arithmetic and geometric. So understanding the common ratio idea, right? And if it's linear, it's like that. So if I have one like, let's go ahead and look at it on your handout. So we want to find, determine if, okay, so go ahead and write it on your scratch paper. Determine if each data exhibits exponential or linear behavior. Linear would be what? Constant, common difference. Okay, so let's look at this one. So on the x's, what is it skipping by? You check on the x values. Does it skip by 5 every time? Skipping by a constant amount every time on the x's. On the y values, what's happening? Is it division? So if it's division, you don't need to divide. You want to always do second divided by first. So instead of divide, you always think times. What am I multiplying by? So you do 32 divided by 64. So you are multiplying by a half every time. So your common ratio is half. I'm halving it every time. So let's write our domain. Our domain for this one, be careful, is not all real numbers. What's the domain in this function? well, this particular pattern. It's
That's
only
X
certain
variable
X
goes
values.
zero.
No. It's
Really?
0, 5, 10, 15, 20. It's those specific values. If you're saying those are the only ones in the set, 0, 5, 10, 15, and 20. And what is the range? Like specific values allowed? 64, 32, 16, 8, and 4. Okay. What about for C, linear or exponential? Linear or exponential. So we know that when I multiply by a constant amount, it has to be exponential. Next one, then what is the expression? What is the what's a possible value? So we said to figure out the nth term or whatever term, right? You could start at the first term times r to the n minus 1. If you follow that format, you're saying y, any value I want, would be the first term times r to the, so the first term is, if in this case we're talking about it being 64, and then each time I'm doing, in this case, if it's not 1, right, if you sub in, let's see, if you want the second term would be, well, it depends, you sub it in, you try it. So when you sub it, you could see if it works. So you'd say, if this is a half, right, every time I times a half, and then what am I going to put here? Why can I not just write x? Why would that not work? Because if I sub x here, it's not correct. Why is this not right? When I put a 0, do I get 64? Now when I sub 0, I'm getting 1. Okay, so you might say, okay, what if I put a 64 there? The first term, what I consider the first term. So you look what happens. This is still not right. When you sub the 0 in, what do you get? 64. What happens when you sub 1?
Should we sub in 5?
No, it's not. Yeah, but I'm saying if you sub in, assuming you're subbing the values, you're going to sub 5, you're right. When you sub 1, you get that. When you sub 2, you get the next one. So I need something to help me get to this multiple of 5. So to do the multiple of 5, you just divide by 5. So if you divide by 5, you check your numbers now. When you sub the 0 in, that gets you 1, which is 64 times 1. The next one, when you substitute 1 in for x, you don't sub 1, sorry, 5 in for x. I skip by 5. So because I'm skipping by 5, I put it over 5. So when I sub by 5, what do you get? 5 over 5 becomes 1. That becomes half of 64. That's correct. The next one, and I sub a 10, when I sub 10, 10 is double of 5. So that becomes half of half, which is 16. So now this is right. Okay, so this is exponential. Let's look at another one. Number 2. So number 2, you've got what situation? Add 3, add 3, add 3. On the bottom, is that add 6 every time? Add 6, add 6, add 6, add 6. Yep, so this is a what? Linear, arithmetic. So linear or arithmetic, yeah. Linear meaning like this. You go up, over, up, over. For every, how many units up? For every 6 units, for every x units, 3. For every x units, 3 units to the right, I go 6 units up. So my slope I can see is rise over run, 6 over 3. Is it 2? My slope's 2, right? So my domain, you write it out as 0, 3, 6, 9, 12. Your range, you write all the y values, which is what? 5, 11, 17, 23, 29. It's linear or exponential. Linear, as we said, right? And what's our linear expression? This is easy, because they give you y-intercept. 0, 5 is given. What's the slope? What's the slope of the line? Pretty clearly, because you have the difference in the y over difference in the x. The change in the y is 6. The change in the x is 3. So we know slope is change in y over change in x. So I take the difference in the y, it's that. Difference in the x is 3, so my slope must be 2. So I have a slope of 2, and the y-intercept is 5. So y equals to slope plus y-intercept. That's the line. Now, if you could sub the points and check each one. When you sub it in, it should work. When you sub 3 in, do you get 11? Yes. When you sub 6 in, it's 17. So you're okay. That is my linear expression. Okay, next one. Number 3. Write the sequence in recursive form or explicit form. So recursive is the one where it's based on the last one. Explicit is a sub n. You just figure it out by substituting n. Let's take a look. What do you think? Is this exponential or linear? Add 6, add 6. This is the linear case. This is the same one as earlier. 5, 11, 17, 23. If you write the expression in explicit, what would you write? You would have, actually, is this right? 5, 11, 17, adding by 6, right? So if you add by 6 every time, we could write this as, in explicit form, you would say this is a sub n is 6n. There's definitely a 6 in it, because I'm adding 6 every time. I'm adding 6, adding 6, adding 6. So you know there's a 6 in the answer. And then to figure out the next one, you substitute 1 in here. So 6 plus what is 5? The first answer is supposed to be a 5. So is it like that? 6n minus 1. That's the easy way to figure it out. You just figure out your skipping. If you're skipping by 6, it's a 6n. You sub n for 1, you get 6, but I want the answer to be a 5, so I know this is a minus 1. Check 2. When you sub 2, do you get 11? Yes, 12 minus 1 is 11. Sub 3, I get 17. So that's my explicit answer. If I know what term I'm on, I just substitute that value for n. What's a recursive one? Recursive is easier. Every time you take the last one and you add 6. So you'd say, my answer is you start with the first one. You always have to define the first term. And then every subsequent one, every n, is you take the prior one, a sub n minus 1. So you're saying the prior term. So if I want the third term, it's the second term if you sub n for 3 and 3. The third term is the second term and add 6, right? The fourth term is the third term and add 6. And you keep going. Right? That's the general pattern. And then you say that for this, you have to set n to be greater than or equal to 2 for the second rule. The first rule follows that. When n is 2, you follow this. When n is 3, you keep going. N is 4, you keep following this rule. That's a recursive answer. All right, next one, top of the page there, number 4. Number 4, what's happening with this one? What pattern is this? Shayna? Domain, oh, domain and range, everyone knows already. So domain is these, range is those. What is linear or exponential? What's happening every time?
Oh, it's exponential.
Okay, it's exponential. And then what would the equation be?
It would be
6 times the, but then you think, what's my common ratio? 3, put the 3 to the power of, now this is a little tricky. So if you're not sure, you first write an x there. You see what happens. When you put an x there, check 0. When you sub 0 in, is that 6 times 1? That's correct for the first one. But the next one, if I sub 2, I end up squaring it. So you know I'm skipping by 2. So if you skip by 2, you got to divide by 2 here. And check your work now. Sub the 2 in. So when you sub the 2 in, does that get you 6 times 3? That's correct. When you sub the 4 in, that gets you 3 to the second power. So that's the next one. That's right. So if you skip by, you have to divide by what you're skipping by, okay, to make it work. Okay, that's it. The next one, write the series, write the recursive. So that same series, 6, 18, 54, 126, or 62. The explicit form answer is going to be what? Different from here because I'm not skipping by 2's. They're just saying using this, assuming they're consecutive. How would I write that? You'd say my nth term is my first term, 6, times common ratio 3 to the power of, is it to the power of minus 1? Yeah, this is the first one. So n minus 1. Check your answer to make sure it works. When n is 1, the first term, that's 6. When n is 2, that takes it 6 times 3. When n is 3, it's 6 times 3 to the second. It works. Next one. What's a recursive one? That's the easier one. Every time you take the prior one and you multiply by 3. So you say a1 is 6. And then any term you're looking for, you take the prior term, the n minus 1 term, and you multiply it by 3. So 3 times of the prior. And then this works for any time n is 2 or bigger. So you're saying when n is 2, you would take 3 times of a sub 1. When n is 4, you put 4 here. It's 3 times of a sub 3, prior n. So that's it. That's a rule. Pretty easy. Next one, number 6. Write the sequence in explicit form. So what's happening with this one? What is our R or our D? Jenna, what's the common ratio or common difference?
Negative half.
Yeah, so this divided by that. So R is negative 1/2. So that's why our explicit form answer. A sub n equals to first term, which is 24, times common ratio, half, negative half, yep, to the power of x. So let's check. So you sub not x, n, because I'm using n. So you n, so when n is 0, that works. When n is 1, that also works. N is 2, yep, that's correct. Then the recursive answer is easier. That means every time you take the prior one and you times by negative half. So you say, I set the first one, and every subsequent one, a sub n, is the prior one, a sub, leave some space here, it's negative half times of a sub n minus 1. Take the prior one times half, negative half. So this is when n is greater than or equal to 2. Pretty easy? This is easy. Recursive and explicit, really easy. Whether or not you're tested on it, it's good to review. Okay, next one, page 2. On the second page, we're doing, okay, the projectile problem, that one. The one where you move it up in the air, you have to solve it. We need to do this one. Yes? Okay. So what is the initial height of this, Let's see what they ask for here. What's the initial height of the object? Okay, let's see what do they have here. So here, I think, did you guys have to end up memorizing this formula or no? You didn't need, they gave it to you all the time?
Yeah.
Always given?
He's
Okay.
gonna give it to us?
Or they'll give you like,
Yeah.
They tell you this is initial, you sub that thing in there, whatever, right?
they tell you like, use this equation to like solve stuff.
Yes, yes. So here, this is what's the initial height of the object. Turns out that the formula works like
Where
this.
is this
It's
from?
h of t
Spanish.
is
And
negative
it's supposed to be
16
US
t
for
squared plus v initial t plus initial height. This is the formula, okay? Assuming this is the formula. Look at this equation. What's the initial height then? This is supposedly the initial velocity. This is initial height. So based on that formula, which one's the initial height? Which term? 3. So I'd start from 3 feet. Yes, what's the initial height? So that means this thing is supposedly 3 feet high, and then I project it up at x feet per second. So it's really being projected at a beginning speed of 22 feet per second. Okay, so it says, for what total amount of time is the object in the air? What do you think? How do I figure out the total amount of time of the object in the air? This is the height of the object. T is time. So what is the height once you hit the ground? 0, right? This is 0. I start out at 3 height. So basically, I need to set h to be 0 and solve for t. Okay, so when you solve it, you're going to get a negative time sometime over here. Because it's a parabola like this, at some negative x, it was also on the ground, but that doesn't make sense. This is t, this is t. So you're going to get some negative t. So some t here is positive, but the other t is negative. Ignore the negative answer. So what you're going to do is set h to be 0, right? So at h equals 0, it's on the ground. It's h naught, right? That little h subscript 0. So here you end up with negative 16t squared plus 22t plus 3 equals 0. You need to factor this one. So factor. We need factors of 16 and 3. So I can try for 8 and 2, 3 and 1, 24 and 2, subtract to be 22. Which one should be negative? Should the 3 be negative? No, right? Because these are both plus. One of these two are negative. So I need the 2 to be negative. So it's 24 minus 2 is 22. Yep. So I get 8t plus 1, negative 2t plus 3 equals 0. T is negative 1/8, which we said you can't have. That's out. The other one is positive 3 halves. So then they ask, what's the amount of time in the air? 3/2 of a second, or a second and a half. Okay, the next one. What's the ball is thrown vertically upward. The height of the ball after t seconds is here, where h of t is measured in feet. What's the initial height of the ball? So looking at the equation, initial height is 504. What is the initial velocity of the ball? Looking at this equation, it's this one here in front of the t. So the initial velocity is 80 feet per second. Okay, C, how many seconds later will the ball be 120 feet above the ground? How many seconds later it will be 120? So you want h to be 120 and solve it. So you're going to say 120 negative 16 t squared plus 80t plus 504 equals 120. Could you possibly hit 120 twice? What do you think?
Yeah.
You can go once on the way up, once on the way down. So you could get 2 answers. Let's try it. So when you do it, let's see. You could divide everybody by, so let's scoot this over. Negative 16, it's going to be divisible by 16, I think. Move the 120 over, so you end up with 3, 8, 4 equals 0. So turns out you could divide everybody by negative 16. So let's do that. T squared minus 5t. This one's divisible. 32, yeah, so 24, like that. I need 2 factors of 24, subtract to be 5. What are they? 8 and 3. Yeah, so negative 8, positive 3. That one's going to be out, so it'll be 8. And then it says how many seconds later will it hit the ground? 8 seconds later. What's this called, where a is not 0? This is called a what? What is this called in this format with the equals 0?
I forgot.
It's a quadratic equation.
Oh my God.
That's what I thought. Quadratic.
Right, what would be in a quadratic expression?
No
No equals 0, exactly. What's the quadratic formula?
The formula.
That, the one with square root, yes.
Yeah.
Quadratic formula is talking about this one specifically. Negative b plus minus root b squared minus 4ac over 2a. This one is quadratic formula.
It looks so much longer in the book.
All right, next one. What does the discriminant tell us about the number of solutions? Discriminant is interesting. Discriminant is which part of the quadratic formula? This part, the one underneath the square root. So underneath the square root, it tells you about how many answers. So let's first think. What if it's greater than 0? If it's greater than 0, so give yourself a sample answer, such as -1 plus minus root, put a number there. Like, put something here. If you put 5 there, how many answers are there? Yeah, 2 answers. It could be like -1 plus root 5 or -1 minus root 5. So if it's b squared minus 4ac is greater than 0, that's the first one. You get 2 unequal real roots. This is called 2, you guys need to know this, huh? 2 unequal real roots or solutions, either way. Just give yourself a sample answer if you can't remember it. Obviously, just say put something in for the square root that's not 0, bigger than 0. Yeah.
What's the extraneous solution?
Extraneous solution is the one we just crossed out like that. It's a one that doesn't count.
No, but then on the test, she like.
Oh, you know, extraneous solutions could be for the squaring cases. That's the case she wants.
Like
Yes.
So like in the original question, there's at the bottom there's
2 answers.
2 answers, right?
You have to get
And
out
then-
one of
yeah,
them.
And then when you
Check your
the
answers.
solution, when you solve it, there's also like another different one. So I put both of them.
One of them's extraneous. Was it a square root question? Was it one that had like x plus 3 equals like this?
No, it's like this simplifying question. So like there's like equation on top.
Yeah.
And then it's a fraction, right? So they're
Denominators for domain, yes.
Yeah.
That's not an extraneous though. It just doesn't satisfy the domain. Is it not in the domain?
It's equal to 0.
Okay.
So like she said like what's the extraneous solution? So I put down the one that's
The not in the domain, right? Or the one that is in the domain, 0.
Yeah, so like she said it's wrong because you only put the one that's in the solution after you simplified it.
So what is she asking? She said, what's the extraneous one? Extraneous is the extra one.
Yeah. I know. And then I wrote that and it's wrong.
Huh. I don't know what she's asking. If it's extraneous, that means it's the extra solution, the one you don't want.
Yeah. But there's also another one.
You're saying that if the top has something, okay, give me an example of what she's saying. You're saying it's a rational, okay, you're saying it's something like this. You guys should all know because you said the teacher wants you to know this. You mean like on the top there's something, on the bottom there's something, maybe it's something like that, and then you cancel this one. That's what she wants, right?
Yeah, but then I wrote that and it's wrong.
Maybe it's...
You only want one.
It's a solving question, right? This is a solving question. It has something blah, blah, blah equals something blah, blah, blah over here, right? You're saying you solved it out. Oh, you did the question, you solved it, it equals 0 like this. You did something, and then you said you cross this out.
Yeah.
That's strange. I don't know what you want to
She
say.
said like, so like
No,
there's
you
a
just-
No,
Maybe she
did it for 3
accidentally,
weeks.
she might have actually graded it wrong. Maybe. That's the only thing I can think of.
Brown is never wrong.
Oh, really?
No, I'm just kidding.
Okay, so then you're saying you did a solving question, but at the end, let's say you did something like this. The only answer should have been -2, but why is this not even an answer? Why can't -2 be an answer?
So is 1 also extraneous if the answer is 2?
No, 1 was never a solution because the domain. Okay, first let's think domain. Domain is x cannot equal to -2 and can't equal 1 because that would make it undefined. Either of these shouldn't even be the answer. But then here, why is the answer not just this numerator equals 0? Because on the bottom, if you say x is -2, what's the problem? It doesn't satisfy the domain restriction, right? So you can't answer that. I don't know what she wants you to say for this. This is supposed to be no solution, no answer, right? Because here, once you cancel that out, is there any x value that would make this 0? 1 over a number is never 0. So it's no solution. But I don't know what she wants you to write. Who knows? Yeah, you have to ask her.
There's still arguing.
Okay, so let's look. Next one, 2 unequal real roots. What's the next possibility? What happens when the discriminant, you guys should memorize it now. What happens when the discriminant is 0? If it's 0, you have like -1 plus minus like this. If it's like 0, then it's the same solution. It's a double root. It's 1 real root. You could also answer this as 2 equal real roots.
I like a whole.
Same roots. 2 real roots, meaning the same answer happened twice. right? It would be like a perfect square scenario. So if I had like x squared plus 2x plus 1 equals 0, what would you answer for this? B squared minus 4ac would be 2 squared minus 4 times of a times c. See how it's 0? When you get that, if you had factored this out,
Why would I know that?
do you see how there's two real roots, two same roots? They're both negative 1. X plus 1 means x is negative 1. So if I get two of the same roots, that would cause your discriminant to be 0. So I just get a perfect square scenario. What's the other scenario? It's when your discriminant is less than 0. That's the easiest one. How come that's the easiest one? Can you have negatives? No, when you have a negative here, it's what? No real roots. Right, so that's the no solution scenario, right? When the denominator, when the square thing under the square root is negative. Okay, look at the next one, page 3. Okay, state how each function relates to the original. So you have to know shifting, right? Transformations. Look at the next page, page 3. Third page. State how the function relates. Okay, so number 1 obviously is very easy. What are you doing? Flipping it with respect to the which axis? We could just talk through them. What is this first one? X-axis, right? So that's the one where it flips here. So when the negative's outside, you flip it down. What does this 2 do in front? The 2 does what? Vertically stretches by a factor of 2. We know it gets taller. What does this one do? You have to do two things. You have to stretch and you have to flip. So what does this negative do here? Flip it with respect to the x-axis, right? Then?
Makes it wider.
Yeah, it makes it wider. You can think of it that way. And then vertically compressed by a factor of 2. Do you guys do that, or do you do by a factor of half? How do you talk about it?
No, we say that it's like wider than the original x squared.
That's what
Wider,
you do.
narrower.
Oh, wider or narrower? There's no, you don't talk about the y value, only talk about the x values. That's what you guys do. Okay, so when it gets like this, I guess it is wider. Okay, so or you can say vertically compressed. So you never talk about the y values, like it's more compressed on the y. No, you just talk about it as like this. Okay, so if it's half, it'll be wider. If it's 2, it'll be narrower. Yeah. Okay, good. This one is a shift. What is a shift? 1 right and 2 down. Down, down, right? Okay, next one. What about over here, number 6? What are we doing here? There's a bunch of things being done. You are flipping, so let's do our flipping first. Let's do this flip. This is flip with respect to the x-axis, right? Okay, so flip with respect to x. Next one, what's the next thing?
Wait, we're doing that?
I think so. Then you do this 2/3. What's the 2/3 do? Vertically times 2/3. But some of you said you never talk about vertical compressions, right? Does anyone talk about vertical compressions, or all classes only talk about the x values?
I don't think we're doing that.
No.
The transformations was in this chapter. Parabola transformations were this chapter.
Wait, it was?
Transformations, yeah, you guys did transformations.
I thought that was like chapter 6 or something. Because I remember I accidentally
But parabolas, no, there's no parabolas. In the chapter on parabolas, it might be in there. I think it might be in there. So vertically times 2/3, or you can think of this as, you can also think of it as horizontally wider than the original.
Oh wait, you might not have us do any. Actually.
It's in parabolas, yeah. So when you think that it's, if this is the original, right? If the new one is supposedly like compressed like this way, you smash it down, it ends up being wider than the original. So some of you are saying that you don't talk about the y values, you only talk about the x values. So it's a wider than the original graph. When you do vertically times 2/3, it's essentially a little bit wider. Just like this, 1/2 x squared. Everybody knows this graph. It'd be 0, 0. Instead of 1, 1, it's 1/2. Instead of 2, 8, it's 2, or it used to be 2, 4, it would be 2, 2. So it's like a wider graph than the original graph. The original graph is 1, 1, 2, 4, like way over here. Right, that'd be the original one. The new one is wider when that factor in front is less than 1. Okay, then the next thing, then you do the shift. So you say 5 right, 1/2 up. All right, next one. Let's look at, turn the page, page 4.
It
maybe not. No.
I think you should well, if you have it, check your parabola chapter. That's the only place where you have transformation, possibly.
No, we
Okay.
had with. I'm
You might have had some.
I'm black.
Okay, page 4. Factor completely. These are really straightforward. Remember, if there's nothing, just factor this one, right? Just take it out. Nothing tricky. Number 2, can we factor further? What needs to be factored further, Kiana? Can this be further factored? Yes, what's in here? 3. What's in the other one? 5, so take them out. Take out the 3 here, so x minus 2. Take out the 5 there, divide by 5. That's it. Next one. This is a what, Jenna? Number 3. What's the best way to do number 3?
Kind of like
difference of squares. So you'll get 2 plus.
2 plus 3 times x plus 1.
No, watch out. 3 times of what? 3 times of, it's going to be 3 times of what?
X minus 1.
No, not 1. There's a 3 there. It's 2 squared minus 3 squared times x minus 1 whole thing squared. So when you write it, it's going to be 3, if you simplify, 2 plus 3 times of x minus 1. You have to distribute that. And the other one's a 2 minus 3 times of, if you're going to forget, then you got to write it out. X minus 1, right? Like that. So then we get what? 2 times of 3x minus 3. The other one? 2 minus 3x plus 3, and then simplify. So I have 3x minus 1, and the other one is going to be 5 minus 3x. Check the binomial. 3 and 1, nothing. 5 and 3, nothing. So you could leave it. Okay, obviously even, odd, even. Even, odd, even. Even, odd, even, odd. That gets rid of some of the factors. 8 minus 3 is 5. I need the negative on the 8, so it's a 2x. Write it across. 2x plus 1, 3x minus 4. This is not a solving question. Do not solve it, right? You just factor. Chi, you got to pay attention. What are you doing? Okay, next one, number 5. From here, 3, 7, and negative 20. So here it's 3 and 1. 20, we need what? Factors of 20 that subtract to be 7. So 5 and 4. That's 15. That's in the wrong order. So probably 4 on the bottom, 5 on top. 12 and 5. 12 and 5. So negative on the 12, right? So it's not this one. All right, negative 12 plus 5. So you know it's 3x plus 5 and x minus 4. Okay, next one, another difference of squares. So on this difference of squares, you think, well, this is 1, here's the other. Add them, then subtract them. Watch your signs when you do it. So if you do the first one, Kayla, number 6, what would you get? So difference of squares, you get what? 2x minus 1. Then? Plus. 3x minus. Yeah, the other one? 2x minus 1. Minus. You already did the minus.
Oh, yeah.
Minus.
I do not play games.
Was that Russell?
Plus
that is
one,
Mitchell.
plus 3.
Plus 3. Change the sign, right? So you're saying this thing plus this thing. This thing minus this thing.
Learn nothing in science?
So you add and then you subtract. When you subtract, don't forget to change the sign over there. So you get 5x minus 4, negative x plus 2, right? Good. And then you check any other factors? None. Okay, so nothing too tricky there. I think next thing, number 7. Many people like to cancel. You cannot cancel x. What happens when you cancel x? You get rid of a solution. 0 is an answer. Factor out. You cannot divide by x. So you have 2 answers, 0 or 7/3. If you cancel, you get rid of 0, and it's wrong. Okay, the next one, number 8. Number 8, you have to what? Move the 20 over and then factor solve. So 3x squared minus 7x minus 20 equals 0. We want factors of this, so it would be 3 and 1, and then 4 and 5. So 12 and 5 subtract to be 7, negative on the 12.
That's like the same as
the same question, yes, except it's a solving question. So we end up with 3x plus 5 and x minus 4 equals 0. Solve it, so x equals to negative 5/3 or 4. Okay, now the next one in here. Those are easy. Let's skip the ones you know how to do. Let's look at number 11. Number 11. So if number 11 can't be factored, turns out it can't be factored if you do it. If you move it over, you can't factor. So 3x squared minus 4x minus 2 equals 0. Quadratic formula then in that case, right? So if they can't be factored, you can do negative b plus minus root b squared, so negative 4 times negative 4, minus 4 times of ac, over 2a, 2 times of 3, which is 6. Simplify, we end up with 4 plus minus root, so we end up with what? 16 plus 12 times that, 24, so it's root 40, is it? Right, so root 40. So root 40, simplify root 40. So root 40 is actually got a 4 in there. We should take the 4 out. So it's 2 root 10. Then divide everybody by 2. So it's 2 plus minus root 10 over 3. Okay, that's one way. You can also do quadratic formula. I mean, completing the square. That's the other way. Okay, turn the page. Next page, page 5. Page 5, what's the best way to do, let's see. Let's do it by completing the square now. Number 2. Next page, complete the square. Well, you have to. What if they ask you to complete the square? Well, technically, you could do it the other way and just say you did completing the square. Well, unless they check your work, right? Did your teacher check your work? They check your work, you gotta complete the square.
This is what I do. I take out a post-it note. I do the quadratic formula on a different day.
And then you check the answer at the work. Okay, so then complete the square. Let's do that.
I work backwards and I work backwards and then I work forwards.
Okay, complete the square. What do we do first? Leading coefficient has to be 1. If it's not, what do? Divide everyone by 2. You're allowed to divide because there's a 0 on the right. So you get x squared minus 4x plus 3 halves. But we might as well move it right away. So I divide by 2, 2, 2. I move this over. Okay, what is my perfect square? What is my perfect square here? Jenna, what's a perfect square going to be? What do I add? It's not 2. What's this one? 4, yes. So it's x negative 2 here. You square that. Well, negative 2 is down here. So you add 4 on the left, add 4 on the right equals 2. Write it as an improper fraction. 2 times 4 is 8. 8 minus 3 is 5. Now square root. So x minus 2, don't forget plus minus the square root of 5 over the square root of 2. You got to rationalize this. So you get root 10 all over 2. Do not leave the 2 on its own. You have to write everything all over 2. So when you bring this over, it becomes plus 2. That's true, 2. But you can't just do this. This is another very common error. What's wrong? Yeah, because that was a 2, not over 2. It was just a 2 on its own. In order to write over 2, it has to be twice as big, right? It's 2 plus minus root 10 over 2. So if that's denominator 2, to make that denominator 2, obviously you have to times that. It has to become 4 over 2. Okay, so anyway, that's it. That's completing the square. Okay, now next one. Let's do number, okay, you're good at that. We're good at this. Let's skip over to number 6 or 7. Let's do a parabola one. This is hard. Number 7. This is the one you guys sometimes struggle with. What's the quadratic relationship? Sometimes you have quadratic. How can you tell it's quadratic? It's the second layer is common difference. Let's check. Add 3, add 5, add 7. Or you notice this is arithmetic. 3, 5, 7. You're adding by 2 every time. When the second layer is the common difference one, you know you're doing a quadratic relationship with a square. But the ones you'll get for these are always going to be the nice ones based on x squared. So you can check here. If it's based on the x squared scenario, you know how it's like this usually? X, y, let's say it's y equals x squared. Usually it's like 0, 1, 2, negative 1, negative 2. At 0, it's 0. At 1, it's 1. 2, it's 4. Notice this. 0, 0, 1, and then 2, 4. Like that. Right? That's a basic parabola. It's you move 1 right and 1 up. You move 2 right, you go 4 up. Okay, now notice this one. Let's see if we can find the same pattern on this guy. So if you're looking at this one, what do you see? Can you find the vertex, basically? So you're looking at move 1 to the right. If you move 1 to the right, it's 1. But when you move 2, this one becomes a difference of 4. You're looking for that relationship. Okay, so this is difference of 5. Maybe there's no nice one. Let me see. 0. Let's see. At 1, I get 1. And then this is not 4, it's 3 off. This is 5, and this is 7 off. I think it's shifted down 1 is what's going on. Let's see. First one's squared. Yeah, I think it's still centered at 0, but it's not written down. So if you go back one more, let's say this is 0. Over here, one more back, what happens to this guy? So the pattern was like 3, 5, 7. So it'd be 3, 5, 7. It should be 1. It should be like there. So it's 0, negative 1,
So it's
right?
curved.
0, negative 1. Okay, so shift it 1 to the right,
It's always curved.
it ends up being 1 up. When you shift it 2, it's 4. 1,
It is that one.
2. This is okay. Anyway, that's the gap that you want. Okay, so if you graph this one, you'll get 0, 1, 0, negative 1, and the next one's 1, 0. The next one is 2, 3. 1, 2, 1, 2, 3, like here. Turns out it's like this. So anyway, it turns out that this one is this one is the vertex. It's not listed. Okay, so it ended up being like that. So 1, 1. So you see that? Scoot 1 right, 1 up. Scoot 2 right, you go 4 up from negative 1 to 3. So it's the same shape, except scooted down 1. Right, shifted 1. Instead of being at 0, 0, at 0, negative 1. So this is going to be y equals x squared minus 1. Then check your answer.
Mitchell.
Check your answer.
Back out to me.
Okay, check your answer then. When you sub 0 in, you'll get negative 1. When you sub 1 in, you get 0. Sub 2 in, you get 3. Sub 3 in, you get 8. Okay, so that pattern works. Okay, next one. Turn the page. Go to page 6. Okay, so radical expressions. I think most of these you're pretty good at. Let's look
This
at
is so
one.
painful.
Okay, look at radicals. Okay, some easier ones here. If it's all under the same root, like number 2, what's a good way to do it? You could actually, here, you could simplify this. It's not too bad. You could reduce this first, but in this case, easier probably just to do that, bringing it out of the radical. The root 18 is a 9, right? So 9 square root is 3. So it's 3 root 2. So that's easy. Okay, how about 72? Should I times root 72? Why is multiplying root 72 not a good idea?
Because it's a big root.
Big, yeah, it's already not simplified. Simplify it first. So this is 9 and 9, it has 8, and that still has 2 and 4. So that's a perfect square, perfect square. Take the 9 and 4 out, right? Take the 9 and 4 out of it and leave the 2 in there. Some of you are not even writing anything. I want you to do the problems. The point isn't just to stare into space while we're doing stuff. You're supposed to be doing a review. No, some of you are not doing anything. You're just staring into space. You should be solving the question then on your own paper. Do it on your scratch paper. The point is to practice while we're doing it, not just sit there. Okay, so here we have 9 and 4. Take it out. 3 and 2 comes out 6. Leave the 2. Then we can,
Someone cut my paper in half. Or, yeah.
so times root 2 times root 2. It's just a scratch paper. So it's a 2 is negative root 2. All right, good. Next one, look at number, maybe the only difficult one in here. Number 8, that's not even that difficult. It's just a FOIL question. So first to first. So 12 times, root 2 times root 3 is root 6. So 12 root 6. Outside, it's 2 times 6, right? So it's negative 12. Inside, 2 times 3, which is 6. Last to last, negative root 6. Combine the like terms. The root 6's are like terms. So it's 12 minus 1, which is 11 of root 6. Negative 12 plus 6 is negative 6. Okay, next one, number 9. What's the best way for number 9?
FOIL, right?
Yeah, this one is just a FOIL question. But
Yeah.
number 9, what do you think? Always simplify the root 12 before you do conjugates. So what's root 12?
2 root 3.
2 root 3. And then, actually, when you get to there, you don't even have to conjugate, right? Because it's a like term. So it ends up being just root 3. And you could just times by root 3 top and bottom. So we end up with 3 root 3 all over 3. So the answer is just root 3. The 3 cancels, right? So a lot of these, maybe you have a nicer answer. Number 10, though, no nice way. You have to times by what? Root 3 plus 1, root 3 plus 1. Simplify it, you get from here. Kiana, what do we get? Denominator? Root 3 times root 3, which is 3. Minus 1. Numerator? Root 6. Outside, root 2. Inside, root 3. What's last to last? 1. Yeah, and then can I simplify those? They're all different. No, nothing on the top can go. So it's just going to be that. It's just going to be root 6 plus root 2 plus root 3 plus 1. Although it's ugly. That's it. That's all you can do. Okay, next one. Turn the page. Page 7. Okay, on page 7, we've got, okay, these are the ones with extraneous answers, okay? So I don't know why your teacher calls it an extraneous answer in the other scenario, but extraneous usually is you solve it, and then I guess you could call it an extraneous answer. You have to get rid of it because of the domain restriction, but this one is not a domain restriction. This is because if a root has a number out here, you don't have to check it. If it's like this, you just square it, right? And you're okay. But if it's ever like a root and it's an expression over here, your root can never be like a negative number, right? This one, whatever it is, this root, whatever you get here, always greater than or equal to 0. It can never be less than or equal to 0 on the right. So you check this on the right. If you have something like sub 16, 13 minus 16 is negative. That would be an extraneous one. You'd have to get rid of it. When you square both sides of an equation, you can introduce extraneous roots. So square it. Square it. Do not make the mistake of squaring it one by one. It's not this squared plus that squared. You have to do FOIL. So it's going to be what? First to first, 1, 6, 9. Twice the product, negative 13 times 2, so 26. And then x times x, x squared. Move everything on one side. X squared minus 27x plus 170. So we're looking for factors of 170 that add up to be 27. It's pretty easy because 170 has a 10 in it, right? So 10 and 17 must be it. So it would be, sum it up, 10 and 17. So I get x equals to 17 or 10. Don't stop there. Every time you square, you have to check for what you do, except if it's a number on the right already. If it's just like 4, you're okay. But here, you need to go back and look. Do they both work? 13 minus 10 is okay, but 13 minus 17 is negative. You got to take it out. So it's only 10, one solution. The extraneous root is 17. Okay, so that's the one thing to watch out for that type. Next type, number 3. Number 3, what do we need to watch out for? Domain restrictions, right? So what should I do? Factor this denominator. Think about which ones you don't want. So here you can see, okay, this is x times x minus 3. What are the domain restrictions? There's 2 of them. 0, negative, yeah, so you have to say domain is x cannot equal to, not that it equals to it, but you'd say x cannot be 0 and 3. Both things it can't be. Can I multiply the whole thing or not? Expressions you cannot, but equations you can. So I can multiply by the denominator. If it didn't have an equal sign, you can't multiply. That's like this. 1/3 plus 1/5. You better not tell me you can times 15 and get an answer. The answer is not 8. That doesn't make any sense, right? It doesn't equal to 8. Can't do that. So if it's an expression like this, you can't do it. But if it's an equation, like it equals to, like if you're doing work rate and you get 1/3 plus 1/5 plus 1 equals 1 over x, like this kind, this one you could times by 15x. But if you have an expression, never do that, okay? So in this one we can't. So we're going to multiply by x times x minus 3. Start there. Mitchell, what do we get? Times it?
You would get
Numerator, so 4x
plus
plus 2. Second one?
x plus 2 times x
Yes,
minus 3.
x plus 2. You multiply it out if you want. And then the next one?
X minus 1 times x minus 3.
Yeah. And then just times it all out, simplify. So you get 4x plus 2. FOIL out this one, so x squared. Outside, negative 3 plus 2. Last to last. X squared. Outside, inside. Negative 3 minus 1. So negative 4. Last to last. And then you can see, okay, x squared goes away. Great. You're left with linear. So we end up with 3x plus 4x, so 7x. That's done. And numbers, 2 minus 6 is negative 4. Negative 4 to that minus that's negative 7. So it turns out x equals to 1. Okay, now 1. Is 1 allowed? Yeah, it satisfies the domain restriction. So the answer is just 1. Done. Okay, next one. Let's try one other one here. Let's do one other one. I'm going to do one with something that can go. Let's check for number 6. Number 6. So number 6, factor that. Both top and bottom there's a bunch of stuff to factor, right? So here you have it. Even, odd, negative on the 1, right? 4 minus 1 is 3. Factor the numerator, the top. So that would be x minus 3, x plus 2. Denominator, 2x minus 1 times x plus 2. Plus 2 equals 3x minus 1 over 2x minus 1. Okay, so what should I be multiplying in this case? What can I do? Olivia?
2x minus 1 and x plus 2.
Okay, so what do you get?
X minus 3 times x plus 2.
Then?
Plus 2 times 2x minus 1.
All those things.
Times 2x.
Or we might as well multiply it. Multiply it out in your head. What do you get? 2 times it? Times these together. So you get what? 2x squared. Are you multiplying these binomials? Yeah, plus 3x, yeah. minus 2 equals to, and that one. And so if you can, you just go ahead and multiply. This one will be 3x squared, outside 6, inside negative 1, so plus 5, lost to last, minus 2. So you need to times everything out and simplify. So you get x squared minus x minus 6 times the 2, plus 4x squared plus 6x minus 4, 3x squared plus 5x minus 2. Okay, so I need all the things on one side. So I have x plus 4x is 5, 5 minus 3 is 2. Okay, that's done. Do all the x's. 6 minus 1 is 5. And that's the same as this. They're all gone. And then do the numbers. Negative 6 minus 4 is negative 10. Negative 10 plus 2, negative 8. So I get x squared equals to 4. So x equals 2. Both plus minus 2. Okay, so let's check our domain restriction. What's our domain restriction? X cannot equal to half and negative 2. So this negative 2 is gone. So my only answer is going to be positive 2, right? Because I have a domain restriction. Don't forget that. Next page. Okay, next page, page 8. Let's see, more of this recursive stuff. This one you said you're not testing. Let's do the next one. Page 9. Let me see. Ball is bounced from... Okay, let's check the look at that one. It says a ball, number 9. A ball is dropped from an initial height of 24 feet. Every time that it hits the floor, it rebounds to a height that's 3/4 of the height of the previous bounce. Write a recursive formula for the sequence. Is this arithmetic or geometric? It times 3/4 times 3/4 times 3/4. Yep. So recursive is easy. A1 is the first initial height, 24. The next, every subsequent one is you take the prior one, a minus 1, n minus 1, right? And you times by 3/4. This is for every single one after the first bounce. This is 2. You take the first bounce times 3/4. The third bounce would be the second bounce times 3/4. Okay, next one. Write the explicit form. So the explicit form for the series is a sub n equals to first term, so 24, times r, right, common ratio, 3/4. Usually it's to the n minus 1, so we can check. Let's write this and check. So if we sub in the first bounce, 1, that's 24, that's correct. Subs 2, second bounce. Actually, yeah, this is going to be, is that right? Write the, let's see, what do we want? Write the explicit form. It's bounced there. Every time it hits a floor, rebounds. So you start from, I guess you can think the first term is 24, the first height. Okay, if we're talking about the heights, the first height is a 24. The second height is a 24 times 3/4. That's right. Okay, you can leave it like that. All right, next one, number 2. Write the first 6 terms of the sequence. It's pretty easy, recursive. The first one, negative 3. What are they asking you to do? Take the last one, multiply by 2, then subtract 3. So times this by 2, so it's negative 6 minus 3, so it's negative 9. And then you do it again. Times it by 2, so it's negative 18, minus 3, so it's negative 21. Times it by 2, negative 42, subtract 3, negative 45, etc. Times by 2, subtract 3, negative 93. Times by 2, negative 186, subtract 3, well, negative 189. That's it. So this is your recursive 3 in there. Okay, next one, number 3. The Fibonacci sequence is neither arithmetic nor geometric. However, it can be written in recursive form. So Fibonacci was the one that starts with 2 1s. And then the next one is the sum of the prior 2. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. You take the prior 2 to add to get Fibonacci sequence. How can I write this in recursive forms? A little bit tricky, but not that hard. If A1 is 1, you have to define the second one. A2 is 1. How would you define the new one? How would we talk about that? To get the next one, so you'd say, if I want A sub n, you can call it whatever you want. You could say, I want the A sub, you could write it a couple ways. You could use n or n plus 2 here, either one. So if you say I want n plus 2, then I take the prior 2, A sub n and A sub n plus 1, both those 2, and then I do what to them? Whoops. Is that right? So if I take like 1 and 1 here, if I sub 1 and 1, so 1 goes for n. So if I put 1 for n, does that get me this? Right? When I sub 1 for n. Is that correct? The third one is 1 plus 2. Yes? When I sub 2, I get 4. I sub 2 there. Yes, the fourth term is the second plus the third. That's it. That's it, your recursive form. Could be this one. Next one, turn the page. Page 10. On page 10, let's talk about Pythagorean theorem. Okay, pretty easy ones. Page 10, Pythagorean theorem to find the third side. Okay, so for this one, yes, you could say this one will be unknown, right? X squared plus 12 squared, 16 squared. There is a shortcut for doing this, but you can also do, I'll show you both ways. When I do this one, usually I like to reduce it. I reduce this by 4. So I like to think of it as 4 and 3. So if I reduce by 4, I put the 4 in right away. I reduce by 4. So I know 4 comes out of the square root. And then you pretend like the question is talking about hypotenuse 4 and leg 3. So you could say 4 squared minus 3 squared. All right, anytime you're looking for, if you're looking for C, if you're looking for C, you sum the squares of A and B. Guys, you see that? C squared is A squared plus B squared. Right? And then you would say what? A is the root of C squared minus B squared. So if you want a leg, you take the long squared minus short squared. If you want the hypotenuse, you sum the squares. Okay, so I divided it by 4 to reduce it down. So I had to put that 4 factor back in. So I get 4 root 16 minus 9. So I know it's 4 root 7. Now let me do it the long way. The long way would be x squared plus 12 squared is 16 squared. Now let's say I didn't reduce it. I just do it and you see what happens. If I do it like this, you get, right, then I have to square root it. The numbers are bigger and it's uglier to do because you'll get 256, 144. You subtract it and simplify it from there. It's not very nice. So you end up with root 112. And then you have to what? Reduce that. So I get 5, what do we get here? 56, 28, and there's another 4 in there. So yeah, 4 and 4 come out. 2 4s come out of the root, 7 stays inside. But it's more work because you have to simplify that square root. So if you can reduce that first, I would reduce it first. Okay, look at the next one. 9 and 12. Look at this one. 9 and 12. What do you do this? The sum of squares, right? So here I can reduce it by 3 to make it a little smaller for myself. It's a 4 and 3. Is that 3, 4, 5? It's a 3, 4, 5 right triangle. So if you realize that, it's 5. But it can't be 5 because that would be if it's 3 and 4. So here I reduced it by 3 already. So put that factor of 3 back in. So it's a 15.
1,000 something. Actually, no.
Okay, next one. This one, there's no, okay, this one you could also reduce if you want. You could say reduce by 2. If you reduce by 2, put the 2 factor right in right away. And then do sum of squares. Square this plus square that. So I get 2 root 11. So it just saves you a little bit of time. You don't have to use a calculator to do it. Okay, do you need to determine if it is a, how do you know if something is a triangle at all? How do you check if something is a triangle? Sum of 2 sides?
Is equal to.
Yeah, greater than. So in this case, guys, add these two, it's bigger than 25. Second two, bigger than the first. So this is yes. Next one, 8 plus 15 is bigger than 18. The outer two bigger than the middle one. The last two bigger than that, so yes. Next one, 2 plus 4 is bigger than 5. 5 plus 4 is bigger than, this one is right. Also, what about the last one? Why does this not work? Because it's not greater than 9. It barely reaches across 9, so this is not a triangle. Okay, next one, turn the page. 11, let me see if there's anything else. That's all the same. Page 12. I think you're okay. Last question, 11. Page 12, number 11. A certain bacteria population doubles every 15 minutes. So this is an exponential question. It is on your test, right? It's on chapter 7. So a certain bacteria doubles every 15 minutes, doubles. There are initially 2 bacteria. So you have to use that concept, like the nth term is the first term times r to the n minus 1, that concept, right? So determine the function, the number of bacteria at time t, where t is the number of hours. Okay, so you start out with 2 bacteria. So you kind of have an idea, and then we want this to do this in hours. Be careful, this is minutes. A little bit tricky.
So it's like a
Different unit. 4 times, yeah, you have to watch out. So 15 minutes, you have to times what to get hours? Times 4. Okay, so be careful with the doubling. Your rate, you can't do, your r is not 2. So you think, what happens every hour? I would do doubling every 15 minutes. So it's 2 to the 4th, isn't it? You have to times 4 to get it to 60 minutes, correct? So that means every 15 minutes I'm doubling. I do 2 and then times another 2, then another 2. So in 1 hour, I would do 16 times. So is this my common ratio then? This is my hourly common ratio. right? This is per hour right now, because the units are different per hour. So now we do y equals to, my common ratio is 16 to the power of t, that's hours. Check your work. At time 1, or time 0, at time 0 starting point, how many bacteria do I have at the beginning? It's still 2, so that is correct.
I'm pretty sure I missed this problem on the test.
And then what's the next one? If you sub in the first hour after that, after 1 hour, am I 16 times more? Yes, so it's going to be 32. And after the next hour, are you another 16 times? So this is correct in hours. The next one, what's the population after 2.5 hours? That means if you already have this equation, should I sub t for that or sub y for that? Obviously, hours would be t, right? So it'd be 2, 16, and then this would be 5 halves. You have to use what? Exponent concept. So it's 2 base 2 to the 4th, all to the 5 halves. What do you do to the powers? Multiply power to power. So 2 times 2 to the 4 times 5 halves is 10. What do you do to this one since this power is here? Add them. So 2 to the 11th. Okay, so you do 2 to the 11th, it's 2048. So you have 2,048 bacteria. Okay, that's it. So that's it. Turn in your scratch paper, turn in your blank packet, turn in your homework. So tomorrow when you guys come in, if you missed the announcement, next week, Tuesday, no class.
Plus the 8, really?
Tomorrow's the review for finals. Okay, you can come between 4 and 7.
Teaming.
So tomorrow between 4 and 7, you can come for a 2-hour period at that time.
Guys, wanna get
No homework tomorrow either.
Katie, help me. Put this back on.